challenge that when I talk to people about like using RAG or using agents is that when you see the LLM doing something cool for somebody else's role, you're like, wow, it can do this for a lawyer. But neither you or I are lawyers. If we were lawyers, we'd be like, yeah, but we don't do this work in this way, right? Or if it were to write the code, I use Claude and ChatGPT to write my code all the time. It's never the first attempt that it has the right code. I have to give it feedback, right? But it's definitely helpful. So I think that's where the challenge is, which is these models seem to do something super cool. To make them do something right in the way you do your work at the scale that you need is hard.
Hey everyone, we have someone very, very special today. His name is Rahul Parundekar. He is a RAG specialist. I've known him for many years, and he actually is one of the most passionate people about ML ops and now LLM ops I've ever met. He started a company called AiHero, which he kind of walks us through the trials and tribulations of and actually what it does today. And then we do a technical deep dive into several different topics. What does it mean for a company to build the right RAG infrastructure? What's the difference between RAG and fine tuning? What are the cost and implementations for both? Where does RAG fail? What are some tricks to get the accuracy up? Techniques that involve both RAG and fine tuning. What we also talk about, where the space is going with the distinction of SLMs and LLMs, techniques of model quantization and distillation and LoRa and therefore and other things as well. We also touch on the challenges of multimodal RAG and how it exactly enhances RAG, and what does it mean for the pipeline, etc. We also go into typical staple questions of like, what does this open source takeover mean for the broader tech space, the AI space rather. And yeah, we talk about, many other things that are very, very nuanced and technical, and that all have to do with RAG implementation. So it's obviously a very topical space today, and I really do hope you enjoy the rest of this interview. Hey, Rahul, welcome to the podcast. Thank you for joining us today.
Glad to be here. Thanks for having me.
Cool. Well, we've known each other for quite some time, and it would, obviously, like I tried to hire you a very long time ago, and failed, but luckily we kept in touch, and you've gone on to do some like fairly interesting things. This is back in the day when data scientists were called data scientists before machine learning engineers. I don't think that was coined yet. You've gone to do some fairly interesting things that you have been extremely passionate about in the ML ops, now LLM ops space. If you could tell us about what that journey was like and how you just became so passionate for LLM ops and where you're at today and so forth.
Yeah, I remember our conversation. It was around the time when I was in between jobs. I think it was like 2019-ish, I want to say. Or was it earlier? I feel it was 2019-ish, right before COVID. But I felt when I talked to you that there's a lot more to learn from you. And so over the last few years, we've had many good conversations as well. And I keep learning a lot. So I just wanted to say thanks for having me here. My backstory, I did my master's back in 2010. The first project I remember working on was agents. It was what would a Siri look like inside the car. I did a lot.
Oh, wow. So you were working on agents in 2010 as a part of your master's.
Well, right after master's, I joined Toyota ITC, which was a research company based out of Mountain View, owned by Toyota. And Siri at that point was not yet a Apple product. It was still a company by itself, and then later acquired by Apple. So the first project that I worked on was what would an experience like Siri be inside the car? And 7 years of my life, I had a great time working with all the amazing people at Toyota. Um, worked on a lot of like real interaction challenges and what does it mean to have an agent that does stuff for you. And so one of the things I'm really proud of what we built out or what we conceptualized, filed numerous patents on, was this proactive agent or the Kiku agent. Kiku means it does stuff before even you say something. So for example, let's say you're walking towards the car, can it lower down the windows and blast the AC so the hot air goes out of on a very warm summer day, right? And things like that. So for me, I've always been in AI, loved doing that. Right after that was when I was working as a director of data science at a data annotation company, and somewhere around that is when we spoke. I really loved that team as well. Me and my team, we built like an architecture that served about 38 different models in production and 100 and about like 1 million predictions per day. So going from that, took a nice year off, worked on my own thing, and then had the amazing opportunity of working at amazing companies, or working with amazing companies like Adept, Llamaindex, and now working on my own thing, which is AiHero. So it's been a very full circle where I come back to AiHero and I'm still working on agents, but there's been a lot of transition in between.
Yeah, that's excellent, and I it sounds like that experience where you were working on agents, call it 15 years ago, whatever. Given today's capacities of multimodal models and the availableness of them and the access to them, tell me a bit about like the challenges and pitfalls that you noticed back then. And how would it have been different if you had something like access to ChatGPT 4.0 today, like in 2010 when you were exploring agents?
That's a fascinating question. So I would say that in many ways it'd be the same, because it's not as much about the language inside the car as it is about control systems, right? It was about the AC, and it's about like the temperature inside the car. Is your seatbelt fastened? Are we heading into a mountainous region? All of these things. And so we were trying to be proactive with this. Now, obviously, with speech and text-to-speech and ASR being at the scale they are right now, it would be an amazing way to kind of integrate that into the car if all the hardware requirements were solved as well. But essentially, the challenges that were like the crux of the research were not necessarily because of AI or not. It was because like, what does the human do inside the car? For example, we spent a year researching this proactive agent. We back then were using
user research, then UX stuff.
Yeah, but like the UX research happened after we did the whole creating the model, creating an algorithm that learns the user's preferences, all of that good stuff. And then when we actually put it in front of a user, the user's like, why is this learning what I want? Why is this not remembering? And so
it had to relearn it over and over.
Yeah,
because
right? Like in the user's mind, they would come inside the car on one day, they'd say set the temperature to 72 degrees. They'd come back. The AI has somehow the ML has learned that hey, this is the outside temperature, this is the inside temperature, this should be your temperature. And it says, oh, your temperature is now going to be 71. And the user's like, why are you just not remembering that? So our competition for AI and ML inside the car ended up being controls that were already present inside the car, like the knob that you turn for AC temperature, right? But the knob remembers. It's not intelligent, but it remembers.
That's a very simple analog solution to something that could otherwise be very, very complicated. So they just kind of like, wait a minute, the knob just stays in the same measurement you last left it. why don't we just run with that for now instead of trying to, build like iRobot or some shit in the car?
And that I'm seeing similar patterns with LLMs now, which is, we're doing these, like, obviously, the research and the effort that's gone into building these foundational models is amazing. The capabilities we see are phenomenal, but there's this. You're already seeing like what was exciting last year is seeing how people are getting cautious about like, hey, is this really what we want to deploy to production, right? And so people are taking a measured approach now with the budgets, with the effort that they do, and how are they deploying agents and other RAG assistants inside the work inside enterprises or apps. And so I'm seeing a switch to the user experience again, which is it's not necessarily about the technology. The technology wow factor has kind of passed in some waves of RAG, etc. But now we're like, okay, when you put a RAG, what questions can it answer? What questions cannot it answer? Okay, how do you, for example, RAG cannot answer, summarize this for me. It just cannot. So you need some sort of multiple tactics to, if it's a summarization question, answer it differently. If it's a search query, then use a RAG. If it's a database lookup, then use SQL tables and so on. So we're starting to see much more of the user experience come inside what technology is.
It sounds like the routing has gotten much more sophisticated based on the query that comes in. So, and I know Perplexity does an excellent job of this, right? Of like kind of really breaking down what the prompt should be, right? From query, from like the hand typed query to what the prompt actually should be. Because it's not a very trivial thing to do so, right? To figure out like what is like the main subject, what are the sub questions that are being asked, and so forth.
Yeah.
And so what you're saying is that these systems are much more sophisticated into like really when and where it should use a RAG, and so. Help us kind of identify the clear use cases where we would use a RAG. Let's just say we are building a chat bot at scale. Help us understand how the RAG system would fit into something like that.
Yeah. So I think like coming back to our earlier discussion, I think where I start is what is that chatbot doing and helping you with, right? Is it just answering search questions for you, or is it doing some actual actions for you, right? And let's keep it simple. Let's say that there's a knowledge base and you want your end user to figure out to get the answers to their questions. So first, you'd need to understand how are you currently doing this manually, or is there a ticketing system or something like you do this with, and understand like how are you solving that business problem without a chat assistant. Then you come to say, okay, now that we have identified this is what the chat behavior should be like, start writing your prompt, right? And you might be like super enthusiastic about it. Let's get into fine tuning. Or use advanced RAG or so on. But let's just try to first use prompts, because what you see is the prompt, the size of the prompt has also gotten a lot larger, right? So with models such as Gemini, we see a 1.5 million token context window. So maybe the prompt and the context being, your knowledge base being inside the prompt itself can solve it. You don't even need RAG. But in many cases, a larger context window would mean slower responses. So at that point, you can say, well, my data cannot fit inside this context window, and we want a faster response. Let's use a RAG system. And for the listeners, RAG is just retrieval augmented generation. When you ask a question, you create a vector embedding out of it. You query a database for similar documents or similar chunks, parts of documents. Synthesize the output using an LLM and give it back to the user, right? So that's the retrieval part of getting the chunks. augmenting it with the LLMs and then generating it. So as you start getting to product,
no. To be clear, those chunks are converted to vector form and stored in a database somewhere.
Correct. And so the query is from a vector for the question to the database, and then you get the chunks that are closest to it, right? And there's advanced RAG techniques as well, wherein from the question you hypothesize an answer, you create the vector embeddings for it, you request the chunks closest to the hypothetical answer, which may help in your case, and experimentation is the way to go. Or it might be other techniques such as like hierarchical RAG, wherein your document is not just chunked, but it's also chunked hierarchically, which is sections have a vector embedding and subsections have a vector embedding. So you can essentially, when you get the question, find out the section and then go into the subsection which has the answer, or vice versa, depending on how you structure it.
Oh, that's interesting. Yeah. So is that another way of kind of locking into a namespace? I know that a lot of people were basically trying to figure out a solution for that, like earlier in the year, at least I've heard. So basically what I'm trying to say is like, if you have a set of documents pertinent to, let's just say I'm a lawyer, right? And it's like I'm interested in like case retrieval, and I want all the documents. I only want documents from this particular case to be associated with it, right? And they could be a variety of things, from medical records to subpoenas, or whatever, court decision, whatever. But the point is that, like, you want it locked, so you don't want it ragging from another case because there's like a similar string in that case or whatever, right? A similar document chunk. Is that kind of what you're referring to?
So the hierarchical one is not. I think what you're referring to is very, very important problem. In fact, that's also associated with role-based access controls, right? Which is, let's say you and I are in the same company. We're usually operating on a similar set of data, but you are privy to some information that I'm not privy to. So when you ask the question, should you use the documents that you have access to? When I ask the question, should you answer using the documents I have access to? So it's role-based access control, which is also these multi-tenancy problems that kind of you're alluding to, which is, can we have separate namespaces? I think multi-tenancy is a problem that different vector databases have taken have approached differently. Some vector databases say, well, create a database for that particular tenant, so all their data is very much separate than everybody else, and then you can query it. But some vector databases have said, well, we just have one vector index and everything's in it. So you can have filter queries and use filter queries to make sure that that data doesn't return when user one's data doesn't return when user two asks the question. And so there's like ways to solve this from a technical perspective, depending on who your vendor is. I think, taking a step back, what I've learned over the last couple of year and a half of building these RAG solutions and working at big companies where RAGs and agents are important, it's like what we've learned over the last year are these tools or these smaller tactics of solving the problem, right? And we need to now stitch them together to figure out, like, okay, this company has a RAG and they are legal, so they don't want one case data to be proliferating into the other case. Let's figure out what are the right things there. Somebody else might be, hey, I'm a medical record system. I want that problem. I have that problem as well. By the way, we have 30 years of data for the patient, which is a lot more medical records. So now you start getting into very different problems about, you might need hierarchical and multi-tenancy, right? So there's ways in which you start pushing the boundaries. So figuring out what works for you is only going to help. You can figure out what helps your case by doing some really good experimentation and observability to give you a clear metric, like, is your model performing to your tests or not?
I see. Okay. So the answer is like, it seems like it's quite nuanced, especially when you're locking in like multiple tenants, as you call it.
And certain data has certain sensitivity, certain data doesn't, right? And so now you start getting into like, okay, what are the compliance issues? especially with enterprises, so you get into issues of like, what is the compliance issue? Can you really answer this question, even if the user asks it and you know the answer to it, right? So
that's right. And so, as you put it, like there are risks, right? Big brand risks there for anyone implementing these types of systems, right? Be it a chatbot or whatever, exposing to the public or not, right? Yeah. It could pull the wrong information and could say the wrong thing. So, as you put it, like, are we even allowed to ask this question?
Yeah.
Is that what you just said?
Yeah. And so it seems like what we're going to get towards is these smaller tooling companies, and you're going to choose in the enterprise what are the tools or what are the approaches that work best for you, right? It's not going to be a one size fits all solution. Like look at databases. Databases have been around since the 70s. We don't have a single database. We have multiple databases, each doing something totally different. Columnar databases are very different than document-oriented databases. And so it's the same with the RAG systems. Like what is exactly part of your RAG depends on what are the problems, what is the problem that you're solving.
That is interesting. I've never heard a RAG system being likened to a database before, but it's certainly, I mean, that analogy certainly makes a lot of sense, right? They're columnar databases so that you can pull up information faster, which obviously, especially if you're like an analyst and you are a data scientist rather, it makes much more sense because you tend to look at data, column by column, right?
Right, and for a banking system, you'd use an OLTP, right, which is like Postgres, your traditional SQL databases, which have atomicity and all of those things. So suddenly, you like as engineers, or we've all been trained, even though we're machine learning engineers and data scientists, we've all been trained in engineering. So we kind of understand these nuances from a database perspective, and we are yet to reach that maturity. But I'm sure in the next year or so, we'll definitely have some more mature understanding of how do we implement RAG.
Yeah, there's quite a bit of maturity that that I've seen it from like 2020, implementing my first like RAG system haphazardly. Yeah. I didn't even have a name called RAG. Yeah. Right? It was just like I'm comparing embeddings versus one another.
Good old days of glove embeddings. We've all been through.
That's right. That's right. So now. Can you tell us a bit about the difference between RAG and fine tuning?
Yeah.
What cost, implementation headaches of both.
Yeah. So I wouldn't.
Where does RAG fail?
Yeah, I wouldn't say that those are exclusive. I think as the company's systems mature, you'd probably need both at some point.
Or go Raft if you're to Raft.
I'm getting it for the first time, but makes sense, right? RAG plus fine tuning is RAG, right?
Fine tune.
There we go. Yeah. So I was originally I was saying earlier that you don't need to start with RAG. Maybe the prompt with all your knowledge base shoved inside the context would help. And then you move to RAG and say, okay, fine, my RAG is answering these questions. But here's the challenge. As you start deploying your model RAG to production, one user asks a question, it answers something that you don't want to answer. So you add one more line in the prompt. Like you say 10 more users, your prompt starts getting fatter and fatter, right? As your prompt gets larger, it starts getting slower. And that's one of those places where I've found fine-tuning to be really, really effective, right? Because fine-tuned models don't need the preamble system prompt. You can, if you have enough data and you have the right ways of answer, like you have the right vocabulary that you want to imitate, you can fine-tune a model for your vocabulary and get done with all the prompts, like do not say this. If the user asks for this, do not reply this, and so on. These kind of rules that you put inside your prompt to make it work.
So this is where the prompt engineering happens, or does this happen in the response layer?
Yeah, so you've in the previous versions, you've had prompt engineering. With fine-tuning, you're reducing the size of your prompt because those instructions are now trained inside the model. And so as you fine-tune the model on your data, you don't need as many instructions. And so your model starts becoming faster. more towards your vocabulary or the way you speak. So, for example, your legal use case that you pointed out, right? There's perhaps a certain vocabulary that you want to use or a certain tone about a legal deposition, and your regular language model, if you wanted it to speak in the same way, you would have had to give it like a paragraph of instructions. If you fine tune the model, you don't need that paragraph of instructions, which means your model is the response is faster. The RAG part of it is separate, which is your RAG can still be there, irrespective of whether it's fine tuned or not. But why I love RAG plus fine tuning combined together is when you have a model and you have the retrieved data, the job of the language model is to only look up the data in the retrieved context, right? It doesn't have to remember knowledge. And for example, if you remember, like back in grade school, here's a paragraph, answer the questions based on this paragraph. That's essentially what we're doing with RAG plus fine tuning, which is fine tuning adapts the vocabulary and the mannerisms of the model, and then RAG gives the context, and the LLM just has to pick the right answer from the context. It doesn't have to remember it. So RAG with fine tuning together works wonders.
That's right. So yeah, I mean, look, I highly encourage you to take a look at Joey Gonzalez's and his team's paper out of Berkeley.
Yeah.
It's excellent on Raft, and he likens it. I mean, the analogy that you painted is quite appropriate. They likened it, if I recall correctly, as someone who studied for the test and still has it's an open book exam for someone who's also studied for the test. Yeah. Right. So you have like a much better accuracy, decreased hallucination, etc. Obviously, like, we didn't get into this, but I'd love to hear your perspective on the implementation costs and headaches and so forth for each RAG and fine tuning independently. And obviously, like, combined, it is combined. So, like, yeah, what's your opinion on ease of implementation? What do you consider as like the simpler solution?
Yeah, the prompt by itself is simpler, but because the prompt is thicker or fatter, your costs are higher because the number of tokens you produce is higher. In fact, just one single data point.
When you say prompt is fatter, do you mean the prompt is much more sophisticated? So like we're using kind of like chain of thought reasoning or something of the sort?
No, it's just the instructions. It's just the instructions and the system prompts are just larger, or your context is all shoved in there. If your knowledge base is shoved in there, it becomes a larger prompt, right? So if you have, let's say, 100,000 tokens in your prompt, a model like one of the larger models that can fit that would cost you like $2 per query. And that's like cost prohibitive for hundreds of queries that one user might have, right? Especially if you're like on a $20 payment plan. So I think that's when you start moving away from just using a prompt to using something like RAG, wherein your prompt and the retrieve context is small enough that you can answer the questions. There is something that I hear is coming sooner or later. I don't know when. I don't know who's going to launch it first, but it's prompt caching. So a lot of times the prompt itself, you could cache in the model, and the amount of time it takes for you to generate the answer is shorter. It's much faster. The other thing it gives you is like the costing is now not per token. The cost of it is now tokens per minute in the cache. But it's a different kind of model which will help us, overcome this fatter, thicker models run slower problem. Now on the RAG side, like I said, it might be cool at first. The moment you start getting into fine tuning, the costs start getting higher again, because fine tuning is basically, you can use one of these off the shelf LLM training companies to charge you per hour that your algorithm is training. But as a data scientist, you train so often that cost balloons up. And then in order to serve it at production scale, you need a model, you need a A100 machine or a A10 machine at least, and that costs like thousands of dollars. So only if like your costs and the value that your customer is getting is higher than that, would I recommend going into fine tuning. And for now, I'd say like maybe start with just the prompt. if you have a handful of customers, just start with the prompt. If you have more, to the RAG, and then do fine tuning. Only if you have like hundreds or thousands of customers and you want your system to be much faster, you want your data to be all in-house, things like that. There's like the design considerations of using fine tuning mean that you account for the tens of thousands of dollars extra per month that you have to pay, and not including the salaries of the data scientists, which is also super expensive.
I see. So that makes sense. There's fine tuning being the most like complex, and this is good. Like, I mean, this is the first time I'm hearing like about kind of an order of implementation, right? Yeah. And it was very clear. We had something like this back in the original machine learning days, where like you just start with the simplest model first, right? Just because due to implementation headaches, and it sounds like it's very much the same case here, where like, okay, instead of, we could get away with like a simple linear algorithm, like what do you call it, a classifier, logistic regression.
Yeah,
we should use that as opposed to training, say a random forest, which it takes a ton of compute power, right?
Yeah, it's Occam's razor. It's Occam's razor.
So, what quick question, like, where does RAG fail? What are some tricks to increase the accuracy of RAG?
Yeah, that's an interesting question. I'd say that not giving wrong answers is the number one way to increase accuracy, obviously. But you also want to not give. So the ways you could do it is guardrails, which is after the fact. So after the answer is generated, you have some guardrails in place that prevent you from giving the wrong answer. But the more correct way of making sure the answers are highly accurate is make sure that the data that goes inside your RAG system is clean, and is, you have to experiment with the chunking, to make sure that the correct context is pulled. Because as you know, like the chunking size, as it varies, the RAG performance varies as well. So you need to do some experimentation to make sure that this works.
Yeah, that's kind of crucial.
so let me give you an example. Like if you
and with the larger context windows, that really helps. So
yeah. So let me give you an example of like bad data going in, bad outcomes, right? If you have a PDF file and the transcription of that, you use some OCR, and the amount of like how much did this company make changed by one, like it failed to recognize a one, right? Digit one there. It's like off by an order of magnitude already. And so your RAG is like, whatever you do with your RAG, it's not going to work if your PDF parsing went wrong. So make sure that those pipelines, the data that comes in is clean. It's in a way that can be chunked really well. And then as you chunk it, as it is retrieved, make sure that your LLM is able to give the right answer, but also know when to not give an answer, like using guardrails, for example.
Understood. Okay, that makes a lot of sense. Now, obviously, like with the proliferation of AI or LLMs, there's going to be a clear continuation of ragging, fine tuning, model evals, and a whole other, like, call it LLM Ops stuff, right?
Yeah.
Like quantization and distillation. Basically making the models much more compute friendly. Have you seen any, can you comment on that? Like, have you seen any interesting infrastructure there?
Yeah, so a lot of the open source models, different companies are coming up with like, hey, we can make this run faster on our custom chips, or because obviously NVIDIA GPUs are short, right? But the biggest, I'd say, is like, we are not at a maturity level yet where we want to optimize on the chips. Obviously, these large companies like OpenAI, Claude, Anthropic, they have hundreds of thousands of customers. They need to think about that, right? I think as you start your company's chatbot, the first thing that you need to think about is, can we move fast and can we iterate rapidly? And in order to do that, the time that it takes you to make sure the model is compiled to a target GPU hardware, instead of that, just bite the bullet for now, use an A10 machine or even an A100 machine with multiple models running to help your users, so that and optimize on the feedback loop, so that when the users use it, the data is available to the product manager. It is available to your data scientist team to update the model or update the prompt for the prompt engineer, and then iterate quickly on the model. If you start thinking about like, how do I will only launch when I have the fastest model ever. By the time you launch, the users are going to be dissatisfied, or the model you launch with, you won't be able to move fast enough if you go with that right now. If you have like the 6-month launch cycles of your model, like GPT, let's say 3.5 and GPT-4, right? 6 months to a year of launch cycle time. That's when you think about like, how do we effectively do this on hardware and optimize there. The other thing that I'm seeing though is on device LLMs being used.
That's right.
There's a couple of players in San Francisco that are fascinating from what they're doing. Olama's a big player, and there's some others as well. Sorry, you were saying something?
No, I was just saying that like we're probably going to see that space explode even more so now that Llama has surpassed the closed source models in terms of capabilities.
Yeah, it's interesting to see that LLMs are being compiled to make sure that they run on M1, MacBook M1 or M2, the GPU hardware that is inside that, or the neural the AI chip that's in there. I think what we're going to see is like the applications that we have had for the cloud, like RAG and agents. We're going to see that on the laptop. Even right now, the first few hackathons that I saw having on-device LLMs were doing all agent kind of work, wherein there's a you can tell the agent in your laptop what you want it to do. The LLM transcribes it, and then you can see the mouse move and click and point and do the actions for you. And so essentially, it's an interesting place where you're saying, well, the LLM stays on your data, so has all the privileges that you have. It doesn't send any data to the cloud. That's great. But then I think the caveat is it also has all the data access. There's no guardrails in place, or there's no access control or role-based, like the stuff we talked very early in the podcast, which was like multi-tenancy and all of that stuff, namespaces. It doesn't have any of that in place right now. So an LLM that runs on your machine and can write a code and execute it has access to all the data on your machine. It may not have privileges, but it does have access. And so that ecosystem is yet to be developed. I don't think we're there yet, but we're seeing these exciting demos, at least, of like LLMs being served on notebooks and laptops, right? Which is super cool.
Oh yeah. Going back to your, original opening to this conversation, we will see an LLM inside of a car, right? On our phones, and a lot of just different gadgets that we have, like everyday wearables, right? So it's going to be an interesting world in the next 5 years, I think.
Yeah, for sure. And who's to say that small action models cannot do the task, or small language models cannot do the task, right? You don't need to bring a bazooka to a gunfight, or to a knife fight. You just need like a smaller model that does very precise work in certain situations. So at the train station, you might need a very small model rather than like this big LLM that can answer who's the president and all the other questions, right? You don't need that. You just need an agent to do its job, right? You don't need it to do everything, right? So perhaps shrinking the size of the models to small makes it much more pervasive.
That's right. Yeah, I mean, there's like a analogy that I used, or and I might have picked it up from somewhere. But have you read Fast and Slow Thinking?
No.
By the yeah. So Fast and Slow Thinking, it's actually they're now using a method from there to displace RLHF's PPO methods, which was later now it went from PPO to DPO, and now it's at KTO, right? I'm just telling you as like the best reward models, right? For these LLMs. But it came from that book, right? That's not why I brought it up. I brought it up because the fast and slow thinking imply that we have mental mechanisms that are more intuition based versus ones that are analytical based. So as you pointed out, like one could be an SLM being utilized, right? That's much more faster reacting because it's less compute. Though it's sometimes inaccurate and fraught with biases, etc. It's just not as robust. Right. That's the short answer, right? But that gives our greater resources to be deployed with our our harder problems that require in-depth analyses and so forth, right? So the bigger LLM, if you will. So that's what I was referring to. Rahul, there was a question that I skipped, and it's pertinent to the ragging stuff that you were just talking about, and the simplicity of certain methods. There are methods that involve, from what I understand, indexing, right? But without putting it into a vector form, right? I'm referring to, min-hash, LSH, regex, compression, and BM25, and etc. Mm-hmm. Can you comment on things like that where, you don't have to put it into a vector database per se to pull it up, to index it?
Yeah, I'll be honest. This is way out of my depth. I primarily work on the infrastructure layer, right? What I'll say is I've seen examples where you don't necessarily need to use vector embeddings to do that. You can use TF-IDF, right? And so,
right, which is like which is a BM25, exactly. But a lesser version of it. Right. Yeah,
and so something like that, which latent semantic analysis and all of these things, information retrieval has been around for decades. You could use some techniques there. Elastic, for example, is a company that's built on top of being able to answer questions really fast, that's indexing right. And all that stuff, right? So you could quickly get the
BM25 is the last time I checked.
So one of those ways you could get retrieve the context is that maybe it's not as semantically similar as a vector embedding is, but hey, guess what? You can instead of retrieving top 4 answers, you can retrieve top 10 answers. And then let the LLM decide which one is better to answer, right? Because at the end of the day, the LLM is going to consolidate the response and summarize the output. But retrieval augmented generation usually doesn't stop there. You can also do retrieval from databases, right? We've seen a lot of whenever I talk to people, some people are exploring hey, how can I run a Snowflake query to get an answer? And perhaps the tabular data that comes out of Snowflake and some data that's been in some document gets combined to give the answer. And so at that point, it's not just RAG anymore. It's RAG, but along with some mixed modalities that you're trying to give the output with. And so that's kind of my depth at which I'm comfortable going with this. But
that's perfect segue. So the next question is literally, what are the challenges of multimodal RAG?
Yeah.
How does it enhance RAG? What's kind of the systems for pipeline look like?
Yeah, and multimodal, obviously it depends on your data. If your data is all text, you don't need multimodal, right? If your data is text and images, great, let's stop. A lot
text, images, audio, video,
exactly.
So forth.
And so,
yeah.
For example, there was a use case that one of my clients or one of my customers for AiHero was exploring. They had a 10K filing and a transcript, earnings call transcript. And so you could say that, hey, earnings call transcript is actually the audio file. You could use the audio file directly. That's great. But they were using the transcript for it, right? So you could essentially combine multiple modalities to answer the questions that you have. the question becomes like, where do you segment? Where do you chunk? Right? What does chunking look like for an audio data? Right. At that point, multimodal RAG can be sort of two ways. One is the data that is inside your RAG is multimodal. The other one is the output that is given is not just text; it's also images. So, for example, you can generate a graph or table. We've seen some amazing things from Claude recently, where it is able to generate some artifacts or some widgets. Right? There was somebody I met recently who is building agents that can write widgets and for a particular question. So if you ask a particular question, the RAG system not only retrieves the context, but it writes its own code, generates a new widget, and then shows the output in that widget. And that's the kind of awesome multimodal things that we're seeing right now.
Interesting, super interesting. Would you call that the most exciting thing you've seen? I know you mentioned
it's new
something about.
It's new for sure, and it's kind of like what's exciting for me is that the agent is generating the code and it's deciding what is the best way in which to represent the information. I think there's some angle of like not just like, hey, we retrieved the question and here's a text of the output, but being able to show it in a tabular form, being able to show it in an interactive form where you have buttons that you can click and the graph changes and so on. I think all of that is more exciting. The modality is, it's like, the way I think about it is this, which is the first chat GPT that came out is more like a messaging app, right? Yep. You say this, agent says this. You say this, agent says something.
Yeah.
What we're seeing now is you can ask a question and it can pop up a web page, kind of a widget. You can play around with it. It has got some answer in this corner, some other answer in this corner. You can click here. You can continue interacting with the agent. And I think that's more interesting for me, for sure.
Yeah, that's like, have you seen that movie Minority Report?
Exactly.
Yeah. I mean, that's interesting to where it's like it can build you an app on the fly, and you're actually like interacting with it.
Yeah. Yeah, and it's not even it's not even an app for the whole thing, right? It's an app only for your answer for this question, right? So it's a very focused widget that just helps answer your question better. And I think we're going to see a lot more of these kind of interesting patterns emerge, especially with the agentic way of doing things. Because in agents, like even RAG, for what we were talking about, you now have people exploring agentic RAG, which is you ask the question, there's an agent that decides how do you chunk it, like in what way do you retrieve the chunks, in what way do you call the SQL query, or do you do summarization, and it plans out what the RAG solution should look like and then give you the response. So we're getting into both like capabilities of LLM wise, some interesting options, but also the architecture wise, you're seeing like some really cool ways of doing RAG.
Yeah, agentic RAG. Yeah, that's a new one. That's a very, very exciting space, indeed. So, what is, moving on to like the do you like indexing questions or like automatic indexing and like Indexify?
I don't think I can answer.
Okay. What about how about this? So open source versus closed source. What's your vision on that? Like, what do you think? If I had no idea. I think a lot of us did not see this big milestone being crossed so soon, where now it's quite clear that open source can at least perform at par to closed source. What does this open up in terms of business capabilities? Maybe I guess like on-device stuff, which is what we described, edge, and so forth. What, in your opinion, new opportunities does this mean for the space?
I really am a big fan of open source. There's plenty of stuff that I use which is open source that I'd love to, every time that I've thought there's a project that I have which can benefit others, I've decided to open source it. the big challenge with open source right now is the model weights at the end are open, right? And you can have these models and you can containerize it and start using it without having to pay um, for a vendor locked model. And maybe you have portability between different clouds, and that's great. But essentially, you still don't know what the data is being used to train it, right? The algorithm that was used maybe is in a paper somewhere, and that's great. But sometimes it's just like, what will decide decision making in the data that is fed in is what you don't know. And so when you decide to use these open source models, well, is this, does it have the same rigorous RLHF loop that was used to train, let's say, OpenAI or Anthropic or Gemini or any of these big companies? So they want to stay on top, and they're putting a lot of money into it. I think that starts becoming the question, because there are some open source models that are really good. There are some open source models which have not taken the right approach to that. So there's, like, for example, earlier versions of image generation were generating copyrighted art, right? And it's not just like about, is this open source model cool to use? It's about, is this the right thing to use, right? And in what ways will other people misuse your model? You want to be more careful about that when you think about open source.
Yeah, I mean, that is definitely a major concern, right? That we don't have with closed source, is that, there's much looser regulation around open source models. And that's something that, I got to get someone on the podcast that can opine as to like what the government is doing about safety regulation and ethics and things like that. I don't think that that gets talked about enough, frankly. But okay, I mean, that pretty much wraps up all our questions for today. I'd love to understand, like, if you could just, give us like 5 more minutes, talk to us about like AiHero, how you came up across the idea. I mean, you kind of mentioned at the head of the call, but it would be interesting to hear about like what you're doing there and advice that you have for founders in the space. Yeah. I know that you had also mentioned at some point that companies are mostly building in-house stuff instead of like canned solutions.
Yeah.
Right. Custom solutions all in-house. Why do you think that is?
The challenge that when I talk to people about like using RAG or using agents, is that when you see the LLM doing something cool for somebody else's role, you're like, wow, it can do this for a lawyer. But neither you or I are lawyers. If we were lawyers, we'd be like, yeah, but we don't do this work in this way, right? Or if it were to write the code, I use Claude and ChatGPT to write my code all the time. It's never the first attempt that it has the right code. I have to give it feedback, right? But it's definitely helpful. So I think that's where the challenge is, which is these models seem to do something super cool. To make them do something right in the way you do your work at the scale that you need is hard. And that's where AiHero is working hard on. So we are trying to make sure that the model can do the job for you in the way you do it. It's at scale, and it can work even when you're not present in front of the laptop. And what this essentially boils down to when I talk to customers and do my user discovery is it's not about the LLM as much as it is about the data that the LLM doesn't have. Because if I was trying to make this decision myself, there's a bunch of information I have from context, tribal knowledge. It's somewhere, but it's not fed into the LLM. And I can make a better decision, or I can automate my task. Sorry, I can do my task much better than AI can automate. And now coming back full circle from the problem I discussed with Toyota regarding like what agent would happen inside the car, what agent would look like inside the car, it's the same thing that we're seeing right now, which is the agent right now the gap between what's in the user's head and the agent is larger than between the agent and the tools that it has access to. And so how do you create a user experience that allows the user to capture their workflow?
Yeah, so repeat that one more time. Like the gap in the agent's head is larger than the access to the tools.
No. The gap between what's in the user's head and the agent is larger than the gap between the agent and the tools. And so
okay, the other way around. So, so basically, again, prompt engineering, understanding AI alignment.
Right. And so making sure that the agent works and does the job the way I want it to do, all of that information is in my head. How do I, like, if I say, find me a coffee shop, it's never going to find the right coffee shop for me because there's a bunch of stuff that I haven't yet told it, right? It's a user experience challenge. It's not like hey, we are going to keep this in the database somewhere and retrieve your old. It's not going to happen as soon. Like it's not happened for the last 10, 20 years. It's not going to happen now. I think what's going to help solve this problem is different, interesting user interfaces. For example, when I'm using these chatbots to do my code, I have the code, I say, do this. It will give me the copy of the code right below it. It's not going to go back and change the code that I just pasted, but it has the ability to do that. And so it's an interface problem. It's not necessarily
why would it need to go change the original prompt out of curiosity?
Because the models are based on a chat paradigm, right? There's different paradigms like you are both collaborating on a single, let's say a code Python file, and you can edit it and the agent can edit it. But we are not exploring those interfaces because we are all stuck in the way all of these larger companies have opened their APIs, right? The biggest way in which you can talk to a ChatGPT, Anthropic, Gemini is using a chat completions API, right? But there's a workflows API that you could have. There's potentially like this interface-based API that you could have. I think that's where the next kind of frontier is of agents. Like, how are we using LLMs to create newer experiences that help us get the work done and reduce the human burden?
That's interesting. Yeah, it makes me really think about. I mean, this is a bit of a tangent, but it makes me really think about the API, right, and how that really, like, what is the analog for an API when you have two LLMs that are communicating amongst each other, right? It's certainly going to be quite different, and it calls for kind of a reformatting or a reinventing of something that used to be the API, right? So now you have two AIs that are multi-agent platforms, I guess. Like, how do we define that, right?
Yeah.
And,
even what you're alluding to, I think when one agent talks to the other agent, what is the handshake? In what way are we delegating work between one agent and the other agent? I think all of those are great questions, and I think we'll see a lot more work being done now that our fundamental foundation models have solved some of the fundamental problems with being able to generate things. Right now, generative AI is at a point where we'll see these interesting ideas come up, and somebody's like AiHero is doing workflows. Somebody might go do the multi-agent language and handshake or negotiation, some stuff like that. And so it's early. It's still early days, believe it or not, and we're going to see some amazing things come up.
So much has happened. Yeah. Anyway, I can't wait for a second round of this conversation. Obviously, your shit. And would love to have you back on the podcast.
Yeah, would love to come back, and thanks for having me, man. It's great. We've known each other for a while, and it's always great to come and chat.
Yeah, likewise.